To become the successful aircraft that it eventually was, the Hunter had to undergo a long and difficult development phase. And this isn't too hard to understand, considering that it first flew only 12 years after the maiden flight of the first jet ever. The Heinkel HE-178 made history on the 17th of August 1939, being the first jet to become airborne. It was too primitive to be of any practical use and was hardly any faster than the piston-engined aircraft of the period. But still, it was the embodiment of a new technique, full of dazzling promise. But at the time, technical know-how just wasn't advanced enough to make these promises come true. However, World War II gave wings to aeronautical research, and in 1942, the first operational jet took off. The Messerschmitt Me-262 was powered by two Junkers Jumo 004 axial flow jet engines, and it outstripped all the other fighters. But it took 2 more years before the Schwalbe was to see actual combat action, and this was too late for it to have any influence on the final stages of the war. The engines of the Me-262 were still quite primitive, with very high fuel consumption and a very short life. Yet, the jet engine proved its superiority during air combat. In Great Britain, research on the jet engine had begun at around the same time. Although the first British jet flew as early as 1941, the first operational British jet fighter, the Gloucester Meteor, would arrive too late to see actual air combat during the Second World War. Another British pioneer was the de Havilland Vampire. The Vampire was powered by only one engine, the Goblin, and hence was slower than the Meteor with its 2 Rolls-Royce Derwents. But by the end of the war, the Goblin was the most powerful jet engine in the world. As a matter of fact, all British jet engines of the period were far superior to those of other countries. And that was something which did not escape the attention of the Americans. The first American jet, the Bell XP-59 Aerocomet, made its first flight, powered by General Electric-built engines of British design. In 1943, Lockheed designed an aeroplane around the de Havilland Goblin, resulting in the first operational US jet fighter, the P-80 Shooting Star. When the Allied armies marched into Germany at the end of World War II, they came across a treasure trove of documents and test reports on Nazi fighter designs. And it was found that German aerodynamic know-how in particular was very well developed. For instance, the swept wing, which was the second step in the direction of higher speeds after the jet engine, had already been incorporated into operational designs. One of the most striking examples of German aerodynamics was the Messerschmitt Me-163. By combining a tailless glider design with a Walter R-11 rocket engine, this small, extremely fast fighter was born. The Comet was built for the same kind of mission that would lead to the genesis of the Hunter. In the shortest time, this aeroplane had to take off, climb to altitude, and shoot down the passing enemy bombers. To fulfill this mission, the Comet carried only a few minutes of fuel, obliging it to return to its base as a glider. One could hardly call the Comet a success. With its highly dangerous landing characteristics alone, the Me-163 was just too fast. The pilots didn't have enough time to get a good shot at the slow-flying bombers, and the Comet literally overshot its targets. However, a very successful swept-wing fighter was to see the light of day in 1947. North America designed a jet with a wing sweep of 35 degrees, and for the first time, after Germany, used an axial flow engine. This type of engine had a much smaller frontal surface in comparison with the British engines, which were all equipped with a centrifugal compressor. Thus, the axial flow engine allowed a more streamlined design of the surrounding airframe. For the first time, a flying tail was used, making the aircraft more maneuverable. The final result was a fighter that made the others look ridiculous, the F-86 Sabre. In one fell swoop, Great Britain had lost its leading position. In February 1948, the British Ministry of Supply published a specification for a fighter interceptor for the Royal Air Force. This aeroplane was to be the answer to the new threat of Russian long-range bombers, but also indirectly to the superiority of the American Sabre. Several constructors came up with a proposal, one of them being Hawker Aviation. At that time, the chief designer at Hawker was Sidney Cam. This man of genius was already responsible for a number of highly successful fighter designs. His first was the Hawker Cygnet, a light aeroplane that first flew in 1924. It weighed no more than 375 pounds, which isn't even the weight of a modern drop tank. Probably Sidney Cam's most successful design was the famous Hurricane. This fighter flew as early as 1935 and in RAF hands during World War II shot down more enemy aircraft than all other British aircraft and artillery combined. A total of nearly 14,500 Hurricanes were built, of which this particular one was the very last, appropriately named the last of the many. On September 2, 1947, the first Hawker jet, the P-1040, made its maiden flight. At that time, the RAF was equipped with the newest versions of the Meteor and wasn't interested in this aircraft. The Admiralty, however, was still looking for a jet fighter that was adapted for carrier-based operations and decided to buy the P-1040. Renamed the Seahawk, the P-1040 enjoyed a certain popularity in the Royal Navy as well as in some foreign navies such as the Dutch Marine. A total of over 550 Seahawks were built. In 1948, the wings of the P-1040 were swept back at an angle of 35 degrees, and it became the P-1052. The tail surfaces, however, remained unswept. An expansion of the P-1040, which eventually led nowhere, was the P-1072, equipped with an Armstrong-Siddeley Snarler rocket in the tail. The P-1072 had a good rate of climb, but after a few flights, the project was cancelled. The first all-swept Hawker design was the P-1081, the first time a straight-through jet pipe was used instead of the forked jet pipe of the P-1040, but the engine itself was still the centrifugal flow Rolls-Royce Nene of the first P-1040 prototype. On the 3rd of April 1951, the P-1081 crashed, killing Hawker's test pilot Wimpy Wade. The cause of this accident has never been quite clear, but it's supposed that Wade, tempted by the all-swept design of the P-1081, had gone for a transonic dive. It's certain that he broke the sound barrier since a sonic bang was heard before the impact. However, the tail of the P-1081 wasn't designed for supersonic speeds, leaving Wade with no effective means to pull out of his dive. On July 20, 1951, the P-1067, the prototype of the Hunter, made its maiden flight. A total of 3 prototypes were built, of which the first 2 were powered by the brand new Rolls-Royce Avon, and the third by the Armstrong-Siddeley Sapphire. After a while, the first prototype, the WB-188, was equipped with an Avon RA-7R, the R standing for reheat. In this configuration, Hawker decided to have a go at the world speed record. Until this moment, the world speed record was held by an American who'd reached a speed of 715.75 miles per hour with a standard production Sabre. Neville Duke pushed the record to 727.63 miles per hour, but the WB-188 wasn't a standard Hunter. It had received a new pointed nose cap and a more streamlined outer windscreen. And no other Hunter would ever be powered by an afterburning Avon, since it was found that the fuel consumption was far too high and internal fuel capacity too low to give the aeroplane any operational endurance. But more important than the speed record is probably the fact that the Hunter was the first British aeroplane to break the sound barrier in a shallow dive. To emphasize their advance, the Hawker test pilots took pleasure in aiming sonic booms at the factories of their rivals, de Havilland and Supermarine, where development was proceeding on the DH-110 and the Swift. Without a doubt, the Hunter was the biggest success of post-war British aviation. But this success was slow in coming. The development of the Hunter saw a long succession of technical problems and frustrations, and by the time the first Marks came into service, its teething troubles were far from over. Number 43 Squadron, based at Lucas, Scotland, was the first unit to receive the Hunter F1 as a successor to the Meteor F8. Next were number 54 and 247 Squadrons at Odiham, and number 222 Squadron, also based at Lucas. The F Mark II was identical to the F1, but it was powered by the Sapphire Mark 101 instead of the Rolls-Royce Avon. The F2 joined the RAF in September 54 with number 257 Squadron, and in February 55 with number 263 Squadron, both based at Wattisham. The problems that the early Hunters experienced were many. Amongst them were radio reliability, canopy misting, and an inefficient air brake and too little internal fuel capacity, limiting flying time to 50 minutes. More serious problems were experienced with the armament. Firing the four extremely powerful 30mm Aden cannon had a number of unexpected effects, such as cracks in the surrounding structure, gases piling up in the front fuselage, and the links and cases that were ejected damaging the underside of the fuselage and the air brake. But the biggest problems were caused by the RA7 Avon engine. When the guns were fired or during certain maneuvers, the compressor surged, resulting in a flameout. The fact that this problem was only discovered on a standard production F1 was due to a silly coincidence. Hawker had carried out the armament tests on the third prototype, which was powered by the Sapphire, an engine that was virtually surge-proof. The Avon was the first Rolls-Royce-built axial flow engine, and like the Hunter, its development was long and difficult. It remains a mystery why Hawker preferred it to the Sapphire, which was more powerful and technically more sound. It wasn't until the new Avon 200 series in the F6 that Hawker's choice proved to be right, and the Hunter got the engine it deserved. A commercial opportunity came up in '52 when NATO decided to sponsor the acquisition of a modern European fighter. An American team of pilots, amongst them Chuck Yeager, evaluated the Hunter against the RAF's favorite at that time, the Supermarine Swift.
I think the Hunter was obviously more maneuverable because it had a lower wing loading and a very good thrust-to-weight ratio. The Swift went in for reheat system, and they had very major problems. Indeed, one with longitudinal control, two with surge problems with the intake engine combination that they were using, and its maneuverability at altitude left quite a lot to be desired. It was evaluated and did not get very much popularity.
As a result of the evaluation, the United States decided to sponsor the acquisition of some 950 Hunter F4s, a part of which would enter service with the RAF and the Danish Air Force. But most of these Hunters were to fly with the Belgian and Dutch Air Forces. Production lines were established in Belgium and the Netherlands, where the F4 and later the F6 would be built under license. In Belgium, the Hunter flew with the 1st Wing at Beauvechain, the 9th Wing at Bierset, and the 7th Wing at Chièvre, where these shots were made. Some of the F4s in these pictures are already equipped with the so-called Sabrinas, the blisters on the underside of the fuselage that collected the links of the Aden ammunition. Sabrinas were named after a well-endowed 50s starlet. The Belgians kept the Hunter in active service for only a very brief period, and they sold it at the first opportunity. The various technical problems that were dogging the aeroplane in these early years had given it a rather bad reputation.
Development problems are an inevitable part of the life of any aeroplane. They are the ones that stimulate a lot of attention in the press, but with development these are overcome, and as the Hunter proved, it turned out to be a very successful aeroplane, but of course it lives with a reputation of some of the early problems that were experienced with it.
Development went on until eventually all the early problems were solved. The wing's leading edges were redesigned, and the wing itself received a number of hard points, allowing external tanks to be carried as well as an impressive array of weapons. New external stores were tested on the Hunter, such as the Fairey Fireflash air-to-air missile, which wasn't accepted, or the drain pipes that came into operational use on the F6. In 1956, a thrust reverser was tested on the prototype of the F6 to shorten the landing distance. However, a braking parachute proved to be less complicated and less expensive. Another development was the two-seater. When the RAF decided to replace its Vampire T-11s, Hawker proposed the two-seater as an advanced trainer. Bill Bedford played an important role in this operation.
In 1959, we wanted to put the Hunter two-seater on the map as an ideal advanced trainer. The board were persuaded to put a powerful smoke installation on the aeroplane so that we could accentuate various maneuvers. But in particular, we wanted to demonstrate the spin and spin recovery characteristics of a swept-wing aeroplane. This was the first time that this had been done in a public display.
And now an aerobatic high spot. Bill Bedford, Hawker's chief test pilot, takes up to Hunter 66A.
My display consisted of low-level aerobatics, followed by a high-speed flypath, then pulling up to 18,000 feet with a smoke on, and at the top, pulling the stick hard back, full opposite rudder, full out spin aileron, and the aeroplane carried out one or two flick maneuvers before settling down into a steady spin, coming down at some 24,000 feet a minute rate of descent. We were demonstrating this in Switzerland on one occasion, and I could see behind me Mount Pilatus one moment, Emmen Airfield the next. I just monitored the RPM and jet pipe temperature, watched the altimeter very carefully, and as my minimum recovery altitude of 6,000 feet came up, I applied opposite rudder, fed the stick for a crack-a-bin spin aileron. The spin stopped instantaneously, and I had this great feeling of professional pride as Emmen Airfield was in front of me. Seconds later, I found the ground was abnormally close, and I was pointing vertically at it. I selected max lift flap, fed on power, pulled to the edge of the buffet in the full knowledge that I was probably going to run out of altitude. The situation got a little less worse, and then I realized that I was going to make it with a few hundred feet to spare, let the aircraft go down to treetop level, pulled up, rolled, landed, taxied in, stepped out of the aeroplane with a smile on my face as if that was part of my normal display, and never told anyone about it till 18 years later. My problem was very simple. The ground over which I was spinning was 500 feet higher than the airfield, and because I'd done an unorthodox letdown into Emmon Airfield, I hadn't reset my altimeter, which just goes to show that even a monkey can fall from a tree, and I very nearly did.
However, the RAF chose the little Folland Gnat as the Vampire replacement. The Gnat became well loved in the hands of the Red Arrows, but it was a disappointment in many other ways. The aeroplane was just so small that some pilots couldn't fit into the cockpit, and it was completely useless for advanced weapons training. Eventually, the RAF bought the Hunter T7 for its tactical weapons units. The Fleet Air Arm also bought the two-seater in the T8 version, equipped with an arrestor hook.
All ready to go. You start up. Low pressure cock on. Throttle closed. High pressure cock on. Master bar on. Press starter button.
The T7 was powered by the Avon RA21 Mark 122 with a static thrust of 7,425 pounds. Basically, this was still the original engine, but with considerable improvements. The aeroplane that was presented by Bill Bedford was the Mark 66, equipped with the Big Avon, a 200 series RA28, providing 10,000 pounds or 4,510 kilos of thrust.
Dunsfold Tower, Hawker 7, takeoff clearance, over.
Hawker 7, Dunsfold Tower, you're cleared for immediate takeoff.
Check RPM and JPT. Brakes off, open to full throttle.
The T7 was based on the F4. Hawker had designed the two-seater in such a way that only the front fuselage differed from the fighter, the rest of the airframe being identical. In that way, Hawker could rebuild the fighters into trainers, and this was regularly done.
Now carry out a loop as briefed. Three and a half G, that's about right. Maintain the back pressure on the stick. Very good. We are now at about 40,000 feet. I'll show you a spin to port. Full left rudder, stick hard back and outspin aileron.
The Hunter had very straightforward spin characteristics. However, trainees were not allowed to provoke a spin on purpose during a solo flight, although, as these pictures show, recovery action wasn't very complicated.
Recovery action, full opposite rudder with stick forward and central. We'll do some more next sortie. Now take me back to base. Speed reduced to 230 knots. Lower flaps and undercarriage. Give the tower a call. Dunsfold Tower, Hawker 7, finals.
Hawker 7, Dunsfold Tower, clear to land.
On this landing, I want you to use the tail parachute. Select as soon as your main wheels touch the runway. Watch your speed. Aim to come over the boundary at 125 knots.
The main advantage of the Hunter trainer over the Gnat was its suitability for weapons training. The aeroplane could be equipped with 1 or 2 Aden cannon, and it had 4 wing pylons, using most of the weaponry that was representative of the fighters of that period. Hawker had chosen the side-by-side cockpit instead of the tandem cockpit of the Gnat. Since the stepped-up rear cockpit wasn't built yet, the Hunter layout proved to be the best for weapons training. The student and the instructor had the same view of the target during aiming, allowing the instructor to make corrections when necessary. Although the Hunter was to excel in the ground attack role, it was originally designed as an interceptor for high-altitude nuclear bombers, such as the Tupolev F-16. And that's why it had the 4 Aden cannon. One single burst from these extremely powerful cannon made the pressurized bombers blow apart. But the power of the cannon posed a number of problems on the Hunter itself. Apart from those already mentioned, another one appeared. When the Adens were fired during a long salvo at altitude, the nose of the aeroplane dipped because of the tremendous recoil. This problem was overcome by fixing blast deflectors which directed the blast downward, pushing the nose upward. Eventually, the Hunter became a very stable aircraft, able to deliver its ammunition with deadly accuracy.
Red 1 turning live.
Red 1, clear live.
Red 2 turning live.
Red 2, clear live.
Red 3 turning live.
Red 3, clear live.
Turn in now. That's right. Don't let the nose drop too low. Now reverse the bank and start wristing forward to keep the sight stable as we're turning in. Don't overcorrect. Now let the pepper come back on the flag. Smoothly now. Red 1 turning live. Coming into range now. Well, that didn't look too bad. Your line was good, but we'll wait till we see how many strikes there are on the flag. Red 3, all ammo expended. Clear, complete.
Because of the good aerodynamic design of the hood, the two-seater was as fast as the fighter in level flight, and it was also supersonic in a dive. The student has taken off for his first solo transonic dive. The early Hunters had very poor longitudinal control, especially at high Mach numbers. Therefore, the aeroplane was fitted with an electrically activated tailplane, which followed the movements of the elevators at maximum deflection. At the end of the 50s, most of the development problems were left behind, and the Hunter enjoyed increasing popularity amongst pilots. And the public loved the Hunter demonstrations by Hawker and the RAF at the annual SBAC shows at Farnborough. The new Avon 200 series engines resisted almost any form of mishandling without flaming out, and the rest of the aeroplane proved to be very reliable as well. It's said that a pilot once put his Hunter through an unorthodox 14G maneuver, although the design limit was 7.5G. However, the only part of the Hunter that broke down was the G-meter. The needle got stuck at the right-hand stop. Without a doubt, No. 111 Squadron contributed to the popularity of the Hunter. These shots showed Treble One looping an incredible number of 22 aircraft during the SBAC show of 1958. No. 111 Squadron at North Weald was one of the first squadrons to receive the F-4. 2 years later, the F-6 came along, and it was on this mount that the famous aerobatic team, the Black Arrows, was formed. At the end of the 50s, defense budgets were relatively healthy, and the price of a fighter aircraft wasn't as astronomically high as it is today. That's why the Royal Air Force was able to put on the massive flying displays that were typical of the period. And nowadays, it's almost impossible to imagine a British aerobatic team composed of 9 frontline fighter aircraft.
Change to card 5. Go. 2, 5. Change to box. Go. Pulling up now. Big formation. Go. Stand by for smoke. Smoke.
Thanks to its agility, its high thrust-to-weight ratio, and its stability, the Hunter was well suited to perform formation aerobatics. In 1960, the Black Arrows performed their last displays on this aeroplane. Even today, more than 30 years later, the Hunter is still flown by an aerobatic team, the Patrouille de Suisse. Switzerland is a politically neutral country and, as for military equipment, just buys what it thinks best, regardless of the politics of the country of origin. So when it planned an evaluation that would lead to the acquisition of a new jet fighter, any country could enter a candidate. The evaluation promised to be very tough, but impartial as well, and it was very clear that winning it meant a big sale. The most important competitors were the Czech-built MiG-15, the Swiss P-16, the brand-new Saab Draken, the French Mystère 4, the Canadair Sabre 6, the F-86, and the Hunter F-6.
Now, the Hunter won that evaluation largely because it had more powerful armament, it could carry more, or it could go further than any of the other competitors. Well, the Sabre was an outstandingly successful aeroplane in that it had a slab tail which gave it very good maneuverability at high Mach number. However, its load carrying capability was not quite the same as that of the Hunter, and the Hunter could either carry twice the warload the same distance or go twice the distance with the same warload. Also, with the large engine in the Hunter, it would outperform the Sabre in terms of climb with fairly similar level speed, but very much better acceleration. But it was a very strong, a very thorough evaluation with the aircraft in the roles of interceptor fighter and ground attack. And it had to be capable of maneuvering in the confines of the Meiringen Valley to prove it had the necessary maneuverability to cope with the mountainous terrain. That evaluation did immense amount of good, because in parallel with the American evaluation, which resulted in the airplane selling offshore to countries like Belgium and Denmark and the Netherlands, It also stamped the aircraft, and the Middle East bought it in quantity.
The first Hunter Mark 58s out of a batch of 100 were delivered in April 58, serial number J4001 to J4100. The Swiss Air Force, like the Swiss Army, is organized to make maximum use of the strategic advantages of the mountains. A number of airfields are implanted in the Alps, using hangars blasted out of the rocks. During a scramble, the aeroplane is pulled out of the shelter and the engine is started during the tow. The pilots of the Fliegertruppe are trained in tactical use of relief. Flying in the mountains is extremely difficult and dangerous, but for a pilot who knows what he's doing, it offers a number of important advantages. When carrying out a ground attack, for instance, it's possible to pop up from behind a mountain at the very last moment, deliver the ammunition, and disappear behind another one before the enemy troops have had time to return fire, or before guided surface-to-air missiles can get a good lock on. Apart from selling 100 aeroplanes, the Swiss evaluation had another important effect on the Hunter program. During the tests, it was noticed that the aeroplane performed extremely well in the ground attack role, for which it had never been designed. Its powerful cannon, its large wing area, its high thrust, its agility, its sturdiness, everything about the Hunter seemed to be designed in for this kind of mission.
Miro 2, risultat 4. Bambini casa libero, mit Granada. Casa 1.
In 1958, the RAF wanted a new ground attack aircraft to replace its Venoms in the Middle East. The original idea was to buy a small, cheap aircraft such as the Gnat or the Jet Provost. Against all the odds, it was the Hunter that won an evaluation at Aden, which resulted in the acquisition of 102 F-6 Hunters. After some minor modifications optimizing the F-6 for ground attack in a hot climate, the FGA-9 was born. By fitting the FGA-9 with a camera nose, it became the FR-10, FR standing for Fighter Reconnaissance. A tribute to the Hunter is the fact that it's still flying today, more than 40 years after its maiden flight. In Great Britain, it's still operated by the Royal Navy, where it's based at the Royal Naval Air Station at Yeovilton. Most of the naval Hunters are GA-11s, basically slightly modified F-4s, fitted with an arrestor hook and a light in the nose. Another Hunter serving the Royal Navy is the T-8 two-seater. The most striking version of this trainer is the T-8M, of which only 3 have been built. It's operated by number 899 Squadron of the Fleet Air Arm to train Sea Harrier pilots in the use of the Ferranti Blue Fox radar. The fitting of this radar led to a completely different radome as well as a special cockpit layout. Apart from this particular T-8M is carrying air combat telemetry pods. This T-8 made its first flight in 1958 and was the first to be converted to the T-8M in 1979. Today, the Hunters of the Fleet Air Arm are operated by the Fleet Requirements and Air Direction Unit, or FRADU, based at Yeovilton, where these shots were taken in 1991. When the Navy bought the GA-11 in the early 60s, it was to be used as a link between the NAT Advanced Trainer and the operational Navy fighters, to provide additional strategic training. A total of 40 ex-RAF F-4s were bought, of which most were converted to GA-11. Some were fitted with a camera nose and designated PR-11. Like the T-8, the GA-11 is powered by the Avon 100 series, which is started by means of cartridges. This T-8 taxis in after a training flight. Judging by the student's helmet cover, it was probably an instrument navigation flight. The Hunter has been in service with the Navy for more than 30 years now, and the aeroplane could be called an old-timer. Most members of the ground crew probably have a shorter record of service than the aircraft they have to take care of, and they treat it with love and respect. They know the Hunter like the back of their hand. The post-flight check has almost become automatic. Thanks to their knowledge and experience, the Hunter can be kept flying for many more years. This technician changes the cartridges that serve to start the Avon, preparing the Hunter for its umpteenth start and its umpteenth flight. And until now, nothing indicates that it will be its last. From drizzly England to the bone-dry south, this is the desert in the north of Chile, stuck between the Andes and the South Pacific Ocean. In this hot and dusty environment is situated the airbase of Antofagasta, home of Grupo Orce. At the end of the 60s, Chile bought some 40 Hunters. Most of them were FGA-71s based on the FGA-9. The remainder were FR-71s and T-71 two-seaters. When General Pinochet seized power during the military coup of '73, 2 Hunters attacked the presidential palace, La Moneda, in Santiago with great precision, forcing the Allende government to surrender. Since 1990, Chile has returned to a government elected by the people, and the Air Force now serves one of the few well-functioning democracies in South America. Because of the strained relations with the neighboring countries, Peru and Bolivia, the Chilean Air Force remains constantly on standby. In the north of the country, patrol flights are flown regularly and the pilots are constantly trained. The aeroplanes have been upgraded by the Chilean company Enair, amongst others. The Hunters have been fitted with a radar warning receiver. This is a device that tells the pilot when his aircraft is seen by the enemy radar, giving him the type and bearing of the emitter. The presence of the RWR is revealed by 3 antennae on the tip of the vertical tail and 1 in the tail bullet. These 2 aircraft, an FR-71 and an FGA-71, are started for a low-level navigation flight, followed by a strafing exercise. The basic FGA-9 was developed for low-altitude flying in the Middle East, and the conditions in this part of Chile are fairly similar. One of the special features of the FGA-9 that's well loved by the men who have to fly in this hot climate is the enhanced cockpit air conditioning system. Heat reduces the power of a jet engine, and it's obvious that the high thrust of the Avon 200 series was one of the things that made the FGA-9 superior to its competitors at the Aden evaluation. Even when heavy external loads have to be carried, which is often the case for ground attack, the Hunter still takes off without any problem, and cruising speed remains relatively high. Any pilot usually claims his aeroplane to be the best, and this is particularly true for Hunter flyers. But in Chile, the Hunter enjoys a particular popularity amongst its pilots. Of course, this is partially because of its exhilarating flying characteristics, but also because of its sturdiness. During a Chilean test of retarded weapons, a fragmentation bomb exploded during dropping, blasting dozens of holes in the Hunter that carried it. Nevertheless, the pilot could continue flying and landed his aircraft as if nothing had happened. Instead of loading the cannon in the aeroplane, Hawker opted for another technique. The Hunter has been fitted with a 4-cannon removable gun pack, which is entirely replaced after each firing session. This operation only takes a couple of minutes, allowing better turnaround time in case of war. The old gun pack can then be checked, cleaned and loaded without the technicians being rushed by a waiting aircraft. Being that the total weight of the gun pack is that of a normal-sized car, specialized equipment is necessary. This gun pack technique was made possible because Hawker chose the jet intakes to be placed in the wing roots, leaving a lot of free space in the front fuselage and leaving the nose free for radar or cameras. This may seem obvious today, but at the time the Hunter was designed, many of the jets had a nose intake, such as the Sabre, the Thunderjet, the Mystère, the Ouragan, and all the MiGs of that period. In the early 70s, Kingston received a new order from Switzerland. The Fliegertruppe wanted another 60 Hunters to expand its existing squadrons. Only this time, they didn't want new ones, but second-hand aeroplanes. 52 ex-RAF F-6 fighters would be refurbished and modified to the Swiss Mark 58A standard. Another 8 trainers would be upgraded to T-68s. The Hunter was designed to last for at least 4,000 flying hours, corresponding to 30 years of operational service. But after refurbishing, the clock could be reset to 0.
Yeah, up he's going, straight up. The end's all right.
Check this first
I know, I've worked my way down
copper in
there.
here, Keith.
That one's all right.
The factory at Kingston still had the original tools and rigs that were used to build new Hunters, and while some of the employees were working on the production of the Harrier, others were carrying out the first phases of the refurbishing of the Hunter. Final assembly was done in Switzerland at the Federal Aircraft Factory at Emmen. The Mark 58A is more than an old F-6. The aeroplane was upgraded with new electronic systems and the engine was also changed. The Mark 58A is now powered by the Avon Mark 207, which is a high modification standard of the original 203. After assembly, the functioning of each part is tested. From the flaps and landing gear down to the smallest detail, everything has to be in perfect working order before the aircraft takes to the sky. The engine is started and checks are made to ensure that it's functioning well. A healthy Avon 207 delivers 10,000 pounds of static thrust at 8,000 RPM. Finally, the Hunter makes its maiden flight after refurbishing, and the test pilot puts it through a number of maneuvers that should reveal possible deficiencies. If no defects are found, the Hunter receives its final camouflage finish and is handed over to the squadron. During the Hunter 80 program that started in 1982, the Swiss Hunters were upgraded to face modern electronic warfare. The aeroplanes were fitted with flare chaff dispensers and RWR, and in addition to the Sidewinder, they're now fitted with provisions to fire the Maverick air-to-surface guided missile. As a result, the Swiss Hunters can't be looked at as old aeroplanes, not even by modern standards, and they'll probably still be operational in the next century. These shots were taken on 14th of November 1991 during Operation Strada 91. A number of sections of Swiss motorway have been planned from the outset to be used as emergency runways for military jets. In case of war, when airfields are damaged because of enemy action, these sections can be made operational airfields in the delay of a couple of hours. In November 91, this section of the N2 near Lodrino was used for the first time. These exercises are not only meant as a training for the pilots who have to land their aircraft in between obstacles such as trees, high-tension wires or bridges, it's also an exercise for the ground troops that have to protect the airfield against enemy attack, and the technicians too are trained in maintaining, refueling and arming the aircraft under exceptional circumstances. During Strada 91, 580 soldiers and 70 civilians were employed. 130 tons of road signs, crash barriers and the like had to be removed. 4 units of radar-guided AAA cannons were installed. 25 tons of material used for communication, maintenance and armament had to be transported. Only 6 hours after the traffic had been derouted, the first Hunters and F-5 Tigers landed on the motorway, and 2 hours after the last jet had taken off, the road was reopened. This is number 11 Squadron, the Patrouille de Suisse. Since 1970, this aerobatic team can be seen at the major air shows throughout Europe, demonstrating the capabilities of the Swiss pilots. But above anything else, this team pays tribute to the flying characteristics and the elegant lines of the Hunter. Some say this aeroplane is the best fighter ever. That's probably an overstatement, but most certainly the Hunter is a pure thoroughbred that's taught a great many pilots how beautiful flying can be.